let's skip to question F on the improper integration worksheet. And this asks for you to evaluate the integral from negative infinity to 0 of 3 over x squared plus 1 dx. So first and foremost, get rid of this improper bound. So write the limit as a approaches negative infinity of the integral from a to 0 of the function. And then just take the integral. So keep on writing this. Limit a approaches negative infinity. You can pull this constant out, the 3. A to 0, 1 over x squared plus 1. And this form should look familiar. This is a trig substitution. This is the inverse tangent identity, and that states that 1 over x squared plus a squared dx equals 1 over a inverse tan of x over a plus c. We're not gonna worry about the c since this is a definite integral. And so, since my problem takes this form right here, I'm gonna identify my x. My x equals x, and my a equals 1. So we already have the answer to this integral right here. So let's just bring down this limit as a approaches negative infinity of 3 times 1 over 1, 10 inverse tan of x over 1, evaluated from a to 0. And now we just do, after you plug in this negative infinity, you just do the top minus bottom. So do 3 times inverse tan of 0 minus inverse tan of negative infinity. So to find what the inverse tan of negative infinity would be, remember that tan equals sine over cosine. And infinity is an undefined number. So at what point on the unit circle is tangent an undefined number? At pi over 2 and negative pi over 2. Because sine will be 0 and sine will be 1 and cosine will be 0. So to get negative infinity, you would have to go to negative pi over 2 to get negative infinity. So inverse sine of negative infinity is negative pi over 2. Inverse sine of 0 is, well, just find out where sine is 0, and that's at 0. So this could be simplified as tan negative 1 of 0 is 0 minus negative infinity, so this is going to be negative pi over 2. And when you distribute the 3, your final answer will be plus positive 3 pi over 2.